Have you ever wondered how these games achieve such realistic and fluent character animations? It is all thanks to a technique called motion matching. Ubisoft introduced motion matching in their game For Honor in 2016. This technique allowed characters to move and react with unprecedented realism, but it was already used in a 2013 game thanks to some clever AI. Welcome to Project X. Project X is a base project and is the result of not wanting to set up a new project every time to test some new idea in Unreal Engine. Now it is just copy and paste and ready to test new ideas. Recently, Project X was updated to run on Unreal Engine 5.4, and the old animation blueprint was replaced with a new animation blueprint that uses motion matching. It is still early days. Both the player character and the NPC use the same animation blueprint, but the NPC has a jitter when moving. Searching on Google on how to fix the motion of the NPC led me down another rabbit hole instead. Back when Control was just an idea at Remedy Entertainment, one of their goals was to have an animation system that is more responsive and don't compromise player controls. The animation system must be code-driven without the need for state machines. While testing prototypes, Ubisoft did a presentation on motion matching. This caught the eye of the developers at Remedy and motivated them to build their own prototype based on the Ubisoft presentation. Early test results shows the technology is viable, and the prototype was deemed a success. With development in full swing and excitement in the air as they built their new IP, it was not long before disaster struck. The animation goals for Honor was simple. The gameplay must be precise and the motion believable. Animation systems consist of state machines and blend spaces, but the developers of For Honor wanted something else. I came across a SIGGRAPH white paper which was released in 2002 on the concept named Motion Graphs, which described a process using an animation database that has an unstructured list of animations from which the animation system selects the best animation to play for the next frame. So the developers of For Honor went down this rabbit hole to see if this is what they were looking for. At Remedy, the development of Control was no more. The middleware that is the foundation of the animation system ceased to exist, bringing all the development to a crashing halt. After evaluating alternatives, the developers decided to build their own animation technology from scratch, with motion matching at the core. The goals set for the new animation systems are: the system must be performant, fast to iterate on, and contain no state machines. Then it was announced that E3 is in 6 months, and they need a functional mission with 4 enemy archetypes and multiplayer, all on the new animation system. One of the design goals for Hitman Absolution was to have 2,200 NPCs on screen, but the developers at IO Interactive only had one problem. Their current animation system cannot handle this requirement. So, the developers went back to the drawing board as they needed a new lightweight animation system that would not only be capable of managing up to 1,200 NPCs on screen, but also be able to automatically decide which animation is best to play in the next frame. The developers created a prototype which was their version of a data-driven motion graph. But the data-driven motion graph was not without any errors. Animation sequence selections would result in errors like foot sliding, as the selected animation frame would not match the previous frame perfectly. The motion graph then evolved into a parametric motion graph, where similar animations are grouped together into what they call parametric motion spaces. In Unreal Engine terms, this would be similar to grouping similar animations into different motion matching databases. The parametric motion spaces addressed issues like blending mid-turning and also resulted in better response times. With the streaming of animations fixed, the developers are presented with another problem: how to decide which animations to play. The developers looked at a technique called reinforcement learning. Reinforcement learning is a type of machine learning where an agent learns to make decisions by interacting with an environment. The agent's goal is to maximize a cumulative reward over time by taking actions that lead to favorable outcomes. This can be seen in action in a August 2023 tutorial released by Epic Games on how to use machine learning in Unreal Engine to train an agent how to drive a sports car around the racetrack. Link in the description. In order to use reinforcement learning in the animation system, the developers at IO Interactive had to define a task goal to achieve, a state representation, and a reward function. The result was an animation system that was able to handle high volumes of NPCs with believable animations and no errors. While Ubisoft was working through the 2002 SIGGRAPH white paper on motion graphs, Matt Butner, technical director at IO Interactive, presented their new animation system at GDC in 2013. Not long after, Matt Butner was helping Ubisoft building their motion matching technology. The result was an animation system meeting all the goals set out at the start of the development of For Honor and became an example for other game developers on how to implement motion matching. Back at Remedy, the animation system was built from the ground up and ended up being better than before. At E3, a full mission with 4 archetypes and multiplayer was presented running on the new animation system. Still on the topic of AI, check out this video to learn even more about AI in Unreal Engine.